Hey folks, this is a video about the setup I have. Magnum sign, inverter, the advanced remote, the panel, and a PT100 charge controller. How I did my wiring on this is from the panel's main breaker. I brought the power in to the positive bus bar and the negative bus bar, and from there, before that I went through a breaker, a 60 amp breaker for the panels, so I can turn them off here or up there, or if something happens it will trip out. A 100 amp breaker between the power track and the bus bar, and everything is done here. So when I'm making power, it first feeds the inverter and it calculates how much power we need, and the rest goes to the batteries. So I only have the 3 out gauge cables that going to and from the batteries to charge, or for usage purposes they serve the purpose. And I have the 250 amp breaker for the inverter, and also I have, as OT calls, the Franken switch here. This is a 600 amp knife blade switch that cuts the whole power to these. So I have that knife blade switch and a breaker, so I have all kinds of cutouts for safety. But anyways, I was talking about the charge. Now we're in float and we're getting about 13 and a half, 14 amps into the system, and that's most of the power that goes to the inverter, because we're at about 26.8 volts and we're drawing about 10 amps, and that's the measure of the amount of the amps going to the batteries. I'm gonna hook up the clamp amp meter to the cable that goes to batteries. So we're getting about 2 amps to the batteries, and the rest of the power, I'm going to lay this down here, the rest of the power that is generating, like 10 amps, is going to the inverter. So it directly is feeding the inverter for the load that is on it, and sends the rest of the power to the batteries. For any reason, if there is a sudden load or a spike on the load, then we'll get more amps to the system. This is more efficient, in my opinion. Instead of running the power to the batteries and then from the batteries to the inverter, we're doing it right there at the bus bars, and with the wiring that I've done, it just cuts a lot of wiring and a lot of heat, and it's more efficient. The batteries are fully charged. We're at almost 26.9 volts at this end, and 26.9 at this end here. And these four batteries here basically work as a buffer, a capacitor for this big bang of batteries. If you get a sudden surge of power request or demand by the inverter, they help out. I took those capacitors out of the line, so they're just sitting there, and I'm not using them anymore. I may use them, I don't know, in future, but I cut down on a lot of clutter that was down there, and the system is working more efficiently. I would say it's 95% more efficient than what it was, and I'm pretty happy with it. This system here that I installed a couple of 3 weeks ago, and I made a video, and I'm sorry guys, I was so tired after doing all the removal, installation, and putting it together. I was so tired I didn't know what to talk about, what to say. But I was so happy I got it running. I had to bring it to your vision, guys. The other thing is I installed this 24 to 12 volt 40 amp inverter converter up here, and it's feeding directly from the bus bar, so that cut down on my clutter too. So we have 24 volts going into the converter, and from the converter we're feeding the breaker for the whole house that feeds the house, the lightings, the miscellaneous, through this cable to the sub panel fuse box that is up in the attic. So I'm pretty happy. I added these breakers here. This is for the converter. It's a 30 amp. It requires a 30 amp fuse, which it does have in the bottom built in, but I added this here for safety reasons, and also it's a cutout. I can turn it off and take the converter out of the loop, and in future I'm gonna add a circuit to this board here, the breaker, that whenever I turn the converter power off, it will automatically send the power to the 12 volt deep cycle battery to power up whatever is hooked up on the 12 volt side of the house. And also, when I turn the switch on the breaker, it will charge this battery, so it'll stand by. And as I mentioned, we have a 63 amp breaker for the panels that is feeding through my incoming power from the panels. It goes in through the panel and comes through this breaker, and from the breaker it goes to the charge controller, and from the charge controller the power out comes to these two breakers that they work together. That's 100 amp. I couldn't find, I wanted to go with 130 amp, but I couldn't find any 130 amp DC DIN rail breakers. I will look forward to find one maybe, or I may leave it alone. So anyways, I'm gonna go to meters. Right now we're at 26.8 volts. We're drawing about 8-10 amps from our solar system, and whatever is left through these cables goes to the batteries. which is about 2-3 amps. It's fluctuating, and I really like this. I really do enjoy how they work together through the system that I put together here. So I'll go to the meters. DC meters. We're at 26.8 and minus 8 amps, which goes to the inverter. DC meters, I was just there, sorry. AC meters, 120 volts, 60 hertz. Timers, AGS, automatic generator start. I don't have it right now. DMK battery monitor kit is ready. State of charge of battery is 100%. I'll go to power track meters. That's the charge controller. That's the PV. We're about 69 volts coming in. Battery volt 26.8. It should be 27, but because of the battery temperature sensor, it reduces to 26.8. Target voltage, there it goes. Because we're at 84 degrees Fahrenheit, it drops it down to 26.8. Battery amps, that's the total amps that are coming in. So we're at 13 and a half. That's what the power track is registering. Power to the batteries, 380 watts. Lifetime 00. I have to learn that. I don't know. Ground fault. Power track data, 2 kilowatt hours. Today max PV volt 71, battery volt 27, and so on. So we're doing good. Again, I apologize for the last video. I was so tired I couldn't talk. I didn't know what to say, but hopefully this is covering everything that has been done. Again, we got about 14 amps coming in. That's what the power track allow to come in. We have about 10 or 8 amps, I would say 9 amps usage through the Magnum sign and the converter. So the batteries are receiving about 2 amps, which makes sense. The other thing I wanted to share with you is the manual for the PD charge controller. It's not that big of a manual. It's about 77 pages. However, the manual for the advanced remote is 140 pages. That came on a thumb drive I had to print it. Look at the size of that thing. But anyway, I'm happy with my purchases and the installation of the system. It's all united and one piece, and so far, knock on the wood, working great. Okay guys, be safe.